Welcome back to the Thane Hines Potential Difference YouTube channel. In this video today, I'm going to answer some questions that have been asked about how do we calculate the generator efficiency. And the first question is, what is an electric generator? Well, an electric generator is a machine that converts mechanical input power to electrical output power. And there's often, with regards to the induction motor prime mover that we're using, there's often some confusion that the input to the prime mover, the induction motor, is the input to the generator, and it is not. Again, a generator is a machine that converts mechanical drive shaft power to electrical output power. It's not a machine that converts electrical input power to electrical output power. So, how do we calculate electric generator efficiency in our setup? The question that we want to ask is, what is mechanical input power? Mechanical drive shaft input power is torque times speed, and at rotational equilibrium, the net torque in a drive shaft is 0. In the comment section below, I will put a document which explains what rotational equilibrium is. And basically, rotational equilibrium is when the net torque, when the system is neither accelerating nor decelerating, and the net torque in the drive shaft is 0. And if the net torque in the drive shaft is 0, the mechanical power in the drive shaft is 0 times the speed, and at rotational equilibrium, mechanical power in the drive shaft is 0 watts. So, how do we calculate mechanical input power on load using our system? We look at the prime mover input on load, and we subtract that from the prime mover input on no load. So we look at the increase in on-load electrical power consumption by the prime mover, and we multiply that by the rated efficiency of the prime mover. And here we have the induction motor efficiency speed curve graph, where we can see that at about 3,200 RPM, where we're operating, the speed of our induction motor is about 70%. So in this test, we're going to look at the input versus the output. The conventional generator, mechanical power on no load at rotational equilibrium is 0 watts. And then we're going to place the generator on load, and we're going to record the values, and then we're going to calculate our efficiency, and we'll do the same thing with the ReGenX generator. So we'll fire up the system, and we'll see what our efficiency is here. Okay, so our system is at rotational equilibrium. It's neither accelerating nor decelerating, and mechanical power in the drive shaft is 0. And now we're going to place the conventional generator on load. And we'll do our calculations. So our prime mover input is 154 watts. Mechanical input is 0 watts. So we went from 154 to 176. So our increase is 22 watts times the prime mover's efficiency at this speed. So our prime mover, our mechanical drive shaft power has increased by about 15.4 watts, maybe less. And our output to our load is .5 watts. Mechanical input increase is 15.4 watts. Our output is 10.5 watts. And the efficiency of our generator as it is about 68% efficient. Now we'll do the same thing with ReGenX generator. Let our system come back to rotational equilibrium. And so we'll place the ReGenX generator on load now. So our prime mover input went from 157 watts down to 152 watts. The increase, therefore, is 0. And we are generating generating 12.3 watts from our load. With the ReGenX generator, we're delivering 12.3 watts to the load with no increase in the prime mover input consumption, meaning no increase in the mechanical power in the drive shaft. And that gives us infinite efficiency, whereas a conventional generator gave us 10.5 watts with a 15.4 watt mechanical drive shaft input power increase and about 68% efficiency. Rotational equilibrium again, 0 mechanical watts in the drive shaft, 0 torque in the drive shaft. Our system is neither accelerating nor decelerating. Now we are in conventional generator mode, and operating at about 68% efficiency. And now we're operating at infinite efficiency. Many people are confused as to what infinite efficiency means. Infinite efficiency doesn't mean infinite energy. It doesn't mean perpetual motion. It doesn't mean that the prime mover can be unplugged and that the system will run itself. Infinite efficiency doesn't mean perpetual motion. That's not what it means. Infinite efficiency, infinite electric generator efficiency means that 0 mechanical input power is required in the generation of electricity. Infinite electric generator efficiency means that 100% of all the electricity that the world will ever require from now until the end of time can now be generated with 0 input energy to the prime mover at 0 financial cost, while producing 0 air pollution and 0 CO2 and 0 nuclear waste. Thank you for taking the time to watch this video. Cheers.